Welcome to the second half day of the INL Hydrogen Summit. Yesterday, we had very insightful moments regarding hydrogen as a viable alternative to non-renewable energy sources on the way to a carbon-free Europe until 2050. Today, we will move right now to the roundtable discussion about opportunities and challenges for an European hydrogen-based economy. We will have in this panel Dennis Thomas, Global Business Development Leader from Water Electrolysis from Cummins Hydrogenics, Luís Delgado, Executive Board Member of Bondalti, Patricia Vasconcelos, CEO of Caetano Bus Industries, Jorge Dot, Director of Wunder Exicon, Luís Mendes, Chief Executive Officer of Windpower, Christian Foduk, Managing Director of Smart Energy Invest, and Didier Stevens, Senior Manager of Toyota Motor Europe. In the final 15 minutes, we will have a Q&A session, so prepare your questions. They are most welcome. To moderate, Stefano Carosio, Executive Director of STEM. So thank you, Stefano Carosio, and thank you to all the invited participants for this roundtable. Right now, please, Stefano Carosio, welcome to the moderation.
Thanks, Emilio and Jorge, for your kind introduction, and good morning, everyone. As time is short, I would suggest that we'll give the floor to our panelists, and I will launch a couple of questions, and we will see where we are after this. The first question would be about the hydrogen economy is about developing new value chains and launching flagship projects and creating capacity to reach the decarbonization goals. Which are the top three challenges that you see from your own perspectives as innovation champions along the value chain? I would start with Patricia Vasconcelos, which is, as Jorge said, representing the Caetano Industries Group. Please, the floor is yours.
Thank you very much. Thank you for the invitation. Thank you for having the opportunity to take part in this event. So yes, we are in very challenging times at the moment. And as you said, there are big challenges in the new value chain that we are creating. And from our side, and Caetano Bus is a bus manufacturer, so we are in the end of the value chain. We are the ones that are going to operate the asset, and that need the complete value chain working in order to have our bus running on the streets. So one of the big challenges we have at the moment is exactly connected to that, is the absence of infrastructure, of the network, the absence of filling stations in order for us to be able to sell our buses to the operators. Still, also a big challenge is the value of the hydrogen. We are the filling stations that we already have, or the hydrogen that we have already available in our customers, is at the moment at a price that is still not equivalent to other solutions, to other transport solutions. And of course, these two challenges lead us to another one, is that we as front riders in the hydrogen technology would of course like to improve our product portfolio and to have new hydrogen products, but not having the infrastructure and having still a hydrogen value that is not really economical for our operators is delaying all this project. And I think these are our three main challenges that we face at the moment from the end user perspective, let's say it like that. You are on mute, Stefan.
Apologize, thanks, Emilio. I will then move to the enabling technology part, the chemistry, and I would leave the floor to Dennis Thomas, which is representing the Cummins Hydrogenics Group, to introduce the challenges from his point of view.
Yes, good morning to all of you. So in terms of challenges, I would mention the time, because in fact the expectations on the hydrogen industry are very high. We need to deliver gigawatts of technologies in a very short period of time, which is very challenging, I would say, for an industry like ours. And also what we see is a lack of established policies. There is a very good momentum on the policy side, actually, at the highest level, at the European level. But we see that there are some key policies which are still missing, even at European level, but also at national level, to actually unlock some projects and actually to have the first projects getting off of the ground. I would say that's the challenge number two. What we see as well, and it's related to the growth of the industry, which is extremely fast. Just to give an example on our side, we had like 200 people working on hydrogen at the beginning of this year. We are now more than 320, but the recruitment of the good profiles in the right locations is, I would say, quite a challenge. That's it for now. Thank you.
Thanks a lot, Dennis. I would then move to Luis Delgado, which is representing the Bondalti Group, which is a large chemical group in Portugal, and it would be interesting to hear from his point of view the challenges as well.
Hi, thank you very much. Good morning. It's a pleasure to be here. First of all, Bondalti, as Stefano said, is a Portuguese chemical company based in Estarreja and having a plant also in Torrelavega near Santander, Spain. So we already deal with hydrogen for a long time. Hydrogen is key for our products. We produce hydrogen from brine electrolysis, and also we consume hydrogen from other sources in our products. Also, we consume ammonia to produce aniline. So we are in a very deep in hydrogen. Let me say economy right now, and it's a very important challenger for us to decarbon to our processes and to make green hydrogen coming true. The main challenges, the three main challenges, and Dennis and Patricia already mentioned a couple of them, but for me, the first one and the most important one is to get the economics to work. Right now, we as a chemical company, we need to be competitive. Adding green hydrogen to our processes, we need a competitive price, and for that, everything has to be taken care along the value chain, energy prices, technology. And so all of these policies, as Dennis said, are critical in order to make this work. Right now, we have a big buzz around green hydrogen, but at the end, we still need clarification how those policies will be implemented and how we can compete for them. This is for me the main challenge. Second one is technology. We need to bring the costs down technology wise to make this everything to work, and we need to support John our R&D development in Portugal, in Europe, in order to bring the costs down, the part of electrolysis and also ammonia production. For us, it's critical to have a technology that can be competitive. This is the second one, and the third one, like Dennis also mentioned, and it's critical for a company like us. It's HR talent. We need to have talent people around. In Portugal, it's becoming very difficult to attract good engineers and people that are aware of both the technology around hydrogen and also to understand industrial processes and how to get them to work. So for me and for Bondalti, these are the three main challenges right now.
Thanks a lot for these notes. I think that you touched upon an interesting point, which is joint R&D development, and I would like to thank INL for organizing this, because I think that they are really at the center, at the interface between business and science, as well as all the efforts that Hydrogen Europe and the European Commission are doing in several initiatives, including the JTI, which is running since a few years. I would then move the floor to Jorge Dott, which is representing a large engineering company involved in floating offshore wind and hydrogen. And I think that it would be interesting to hear from an integrator perspective, which are the challenges.
Thank you. Thank you very much, Stefano. And thank you for inviting us to this event. There are a lot of challenges with hydrogen, and perhaps the first one is education, because when you talk to people about hydrogen, nobody knows nothing about it. Someone thinks that it's something that is going to explode. So we use hydrogen in our industry, but we are not using yet hydrogen for the end users, and it's important education and marketing around the hydrogen. In our field, we are developers of technology offshore wind, floating offshore wind. And we have here a lot of challenges. The first one is to reduce the cost of the energy in order to produce affordable hydrogen, green hydrogen. But also what we want to do is to produce this hydrogen offshore. And it is possible because offshore is where we have the best resource of wind, for example. So for us, the first challenge is to be able to produce offshore green hydrogen and to sell it from our platforms, is in what we are working now. Thank you.
Thanks a lot, Jorge. There is another engineering company representative, which is Luis Mendes from Wind Power. I think that they are an APC, they are covering the whole value chain, and it will be interesting to hear as well from himself. Is Luis with us? Not really. Then I would move the floor to Christian Poduk, which is representing another key important stakeholder in the value chain, which is the investment world, and is representing Smart Energy, which is involved in development projects, investment projects in the renewable energy field and hydrogen. I will leave the floor to Christian then.
Thank you very much, Stefano. I'm very happy to be here, and also hello to all the other speakers here. In fact, I think one topic is to get all the parts in the value chain together right now at the same time with the same dedication and kind of risk-taking in the beginning. And it goes together as a topic, maybe as a one keyword is the bankability actually of the projects. We're coming from the investment side. There's a lot of capital available, but obviously, and also great interest to invest into green assets. And hydrogen is the new kid on the block. And however, we have the same situation as in the early PV days, however, even more complex than just the PV side. As the value chain is much more diversified. So we see the three major points in the bankability: the technology, the off-taking, and the governmental support, which is needed in the beginning. On the technology side there, I'm quite confident. I mean, there is a clear path to move and etc. So this is going the right direction. Maybe except the comment that the water topic connected, how to get the water in special regions is something new to develop on the technology side. The off-taking, however, is something really which is something new and to be overcome, because we need kind of long-term off-taking agreements. And for example, in the gas business, it's not the usual way to do a kind of 20 years agreement as we knew it initially from PPAs of 15 or 10. So it's a complete different model, which, however, is needed for bankability. And this gets me to the third part of this bankability is that the governmental support must really take into account, if they want to have the scaling, there needs a policy in place where the investor trusts that this is sustainable on the long term. So this is the one top topic, bankability. The second is permitting legislation. Maybe in a call discussion later, we have more time to talk about in detail. But I think the permitting on the hydrogen, green hydrogen now is a very important topic, that it gets a new kind of a fast track possibility to implementation, and not a very industrial type of approach, pure industrial, because it's a different animal right now. Green hydrogen is not an industrial factory as it used to be. And last but not least, transport logistics, I want to mention as last. Third challenge I see on the generation side, we are quite ahead, but looking into how this huge amount of hydrogen is then being transported, the connected costs, this is something which I think there is a lot of more work to do. These are my three top topics.
Thanks a lot, Christian. Indeed, the policy was touched upon by many of you, and I think that what I saw since 15 years ago, when it was more a technology challenge, now with DG Growth, the European Commission launching the European Green Hydrogen Alliance, I think that the policy side is trying to understand from the project point of view which are the barriers, and I think this is another big change that I see clearly in the landscape. Going to the second question, you all mentioned that connecting the dots, creating value chains is a big obstacle. I think that the collaboration, university, research institutes, and business would be a key, and also the creation of new professions, multidisciplinarity, I think would be key, as it was in the past, maybe for nuclear energy. I think that there is a need for new professions. But which are, from your point of view, the new skills and the new profession that will come in place when you are mentioning, let's say, shortage of resources, human resources? I would start again with Patricia, sorry.
Sorry, I had to. Okay. Again, talking from the perspective of the end user and of the as a manufacturer of buses. Of course, we are talking here about engineering capacities, about skills around the technology of hydrogen, around the processes, how to build the buses with hydrogen. So this all we really need specialized personnel to guarantee not only to develop the bus itself or to develop the asset, but also then to guarantee that the production, that the quality control during production, and then of course after selling, the after sales support services are with all the knowledge that we need in order to support our customers with this new technology. New mobility solutions and innovations, of course, they require competences that we don't have at the moment. So the universities are helping us a lot. And much more than the mechanical side, that we are very well already with the mechanical side at this moment, we really need qualified and specialized mechatronics and people that support all the technology, all the hydrogen technology in the vehicles. And this is something that we are building up at the moment. We need to start immediately with this, and we have already started at Caetano, because we need these professionals now in order to be able to fulfill the market needs on a horizon of a few years. So it's really key now to have the universities with us, but more than engineers, we also need the people on the ground to have skills on the hydrogen, around hydrogen. So this is from our perspective, this is what we need. And as it's not really viable at the moment everywhere, we have the universities, but we at Caetano are also creating competence centers and making the trainings and giving trainings to our people internally.
Thanks, Patricia, for your inputs. I would then move to Dennis, if still with us.
Yes, thank you. And I already need to apologize because I need to leave this conference in 5 minutes. But concerning the recruitment, which I've already mentioned, I would say in the first intervention, I think, yeah, we need especially technical skills and engineers like electrochemists, welders, electricians, process engineers, mechanical engineers, automotive engineers, people which are also able to work on safety. And so these are, I would say, critical skills for the manufacturing of water electrolyzers and also for fuel cells. Concerning more like the commercial functions, considering the complexity of hydrogen and the role it can play actually in the various sectors, we need people with a good understanding of those sectors. Not only about power, but it's also about the gas sector, the mobility sector, the industry sector, etc. What we see is that there is a good potential actually to tap into the existing industries like the oil and gas industry. A lot of those skills and also quite some motivation actually to move to, I would say, a clean sector like hydrogen. One of the difficulties is the high pay grades of the people working in those sectors, which is not really in line with actually the cost reduction that we are looking into our technologies. How we tried actually to bridge the gap in this, I would say, growth actually of our industry is that we are a global company. And so we try to work with the people with the skills in their own countries. And especially now with COVID, I think, I'd say remote work is becoming quite of an habit. And so we have, I'd say, people in Belgium, Germany, Canada, and the US, which are actually working in a collaborative mode. And we try to recruit people on those different locations at the same time.
Thanks a lot, Dennis. I would then go to Luis from the chemical company point of view.
From our point of view, it's I don't think we need any specific new competencies or new skill. Well, what we need, I think, it's, and someone already mentioned, is we have to educate people on what is hydrogen, what is green hydrogen. When I say people, is people that are in universities, especially in, of course, engineering, and especially in our case in chemical engineer, to be able to view hydrogen as an opportunity, not only from a technological perspective, but also from an integrated perspective, where you link engineering to the objectives that we have in terms of decarb our processes and to be able to be a more sustainable company and to have a more sustainable business in the future. So to have this mix of good technical skills and also a strong view on how to be sustainable and to have to have a business in the future is something that we have to have on all the people that we hire just for the green hydrogen projects that we are building. And there is also a topic that is for us very, very important, and we need people, of course, with these skills, which is safety. Safety is and will be very, very important in everything related with hydrogen. Hydrogen is not easy to handle and to transport and to storage, so to have storage, and so everything around safety will be critical in the future. So I think skills around safety will be also very, very important in the future.
Okay, thanks a lot. I would then move to Didier Stevens from Toyota Motors. He's representing the UFS department. Which are the skills and the needs in terms of knowledge from the perspective of an automotive and big group? Didier? Where is mute? Didier, we don't hear you. Hello? We cannot hear you, I think. Maybe I can move to Jorge just to give his point of view about the skills need.
Okay. Thank you.
And then we move again to Didier.
Thank you, Stefano. Of course, we need researchers and we need engineers. But I think that what we need is believers. We need people ready to enter in a new business, in new developments. So what we need, in my opinion, is business developers and believers.
So business developers are the main need.
Yeah. Business developers is very important now because this is a new business, a new activity for a lot of industries, for the whole value chain. So it's important to have in your team.
But to be a good business developer, which kind of skills do you need? Because I think it's very complex to sell, the hydrogen economy as a whole.
Yes, of course. You need. It depends on every industry. In our case, we need researchers and engineers. But what I mean is that we need people believing in this business, in this new business, and it's important to risk. And when you develop new business, you are risky. So this is the most important skill that we need now.
Okay, thanks a lot, Jorge. Didier, are you able to get connected? Hello? I think we have a technical problem with Didier. I would then maybe move to Christian again, and then we close the loop with Didier if available to speak. Christian, what about the skills from your point of view? I mean, you are an investor, so it's interesting to hear from you the opinion.
Okay. Well, besides a lot which has been said, which I fully agree on the specialists. On one side, we are striving for, in the end of our equation is the IRR of the projects, and then we look into the factors which mostly how can I say influence this case, and going there you then come out that as electricity is one of the major factors, and then the efficiency of the hydrogen generation, these are kind of super important topics. The integration to make the maximum efficiency out of the value chain is something which is a kind of more complex system integration we have seen before. It starts already in the generation side, where you have so many different options now. You have the size of the renewable energy source, you have the electrolyzer sizing, you have the battery sizing, which mostly will be kind of apart, even if it's for short-term storage. You have injection into grid, gas grid, water usage. Should have an integration, and then didn't mention the whole off-taking side and the different value chains. So, and in the end, the total efficiency is the essential to make a business case. And so I think what I see as a expertise which is really needed, somebody being able to understand the full value chain also in terms of efficiencies, and with that in the end also improve the business case. So that's one of many points, but I think this is one I wanted to mention today.
Okay. I don't know whether Didier is now able to
Can you hear me now?
Yes, Didier, fantastic. We are online.
Good, excellent. Good,
fantastic.
okay.
Can I take
Sorry.
I take the advantage that you are now with us, and I think we have still time to go back to the first question, because I think that we missed your contribution, and it was about which see as main challenges for an automotive group perspective in the hydrogen economy.
Well, for us, of course, I support all the challenges that have been quoted already this morning, but for us, it's mainly time, scale, and standards. In the sense that technology for us is there. We had the first generation Mirai, we're introducing a second generation Mirai. We are inserting our technology into boats and into buses like the Caetano bus. But time and scale is when it comes to develop and to get to a break-even project. We need, whenever we discuss projects with people, it's always about, how fast can you do it? How big can you do it? and it's always, you need many actors. That is the problem here. You need many actors. Before, when, you know, for traditional vehicle, you can say, yeah, I will put my vehicle on the market because I know there is an infrastructure, refueling infrastructure, everything is there. But for hydrogen, it's something completely new. You need also the cooperation with energy suppliers, with hydrogen suppliers, etc. So you need many things, and you need to have a whole pack. That is the problem, and there you need time and scale is an issue. Another one is standards. Hydrogen is to a certain extent relatively new. Some standards and regulations are still missing. For instance, on the volume, on the debit to refuel a truck, we still do not have a standard. So, and that prevents a little bit sometimes the deployment of these new technologies on the market. Okay. So that is mainly for us. These are the problems. When you talk about skills, because you were referring to skills, we are cooperating with universities. We receive numerous demands for establishing R&D clusters in, I would say, in almost every single country. We cannot do that. We just centralizing our R&D capabilities here in Belgium. It's because it's Toyota. It's not so difficult to attract people, but of course there are not many. They are not numerous today. More people needs to get interested into hydrogen, because it will come. There is no doubt, and we have no doubt hydrogen will be one of the major energy sources in the future for transport. It can be for aviation, it can be for trains, it can be for vehicles, it can be even for drones. You know, it can be for boats, it can be for everything. It will come. But we need to get people interested into hydrogen. There is a little bit of a misconception or misunderstanding about hydrogen, and that we need to get out of the way to attract young people to study hydrogen, to really qualify into hydrogen skills.
Okay, thanks. I think that this is indeed a big challenge to create awareness.
Yeah.
A few years ago, the Commission started talking about projects of common European interest, and at that time there was an exercise to identify the strategic value chains, and hydrogen at the end resulted as one of the strategic one. I know that many European countries has launched expression of interest to understand potential project to apply for this specific scheme instrument, which is joining forces between Europe and the member states. I would like to hear about your experience in this framework, because I know that Portugal and many other countries are now in the middle of this nice exercise. I will start from Patricia then. What about your experience with project of common European interest?
Yes, Stefano, like you said, Portugal, fortunately, is really making a lot in this direction. And in order to achieve the carbon neutrality that we need in 2050, of course, we need really to reduce the emissions and to invest in these reductions. And as Didier also said, I mean, we completely believe that this reduction has to come through hydrogen, and that hydrogen is going to play a fundamental role here. And that's why we see that in order to get scale, in order to get competitiveness, we really need to work together with the governments. And as we said, Portugal is doing a lot. We fortunately have already, we are participating in governmental programs. We have, in the case of Catanubas, we are participating in a collab project, meaning we are making a competence center in order to be able to develop, adapt, and optimize our fuel cell that we have in the bus already, that is from Toyota, the technology, that we can then also have this technology passed to trucks or to rail, to trains or to freight assets. So I think this is one of the applications we have with the government at the moment. There is also another incentive going on with the region Médio-Tejo. Médio-Tejo is divided into a hydrogen valley, and we Caetano Bus as an end user, again, of course, our interest, we have interest in this project, because we will then of course be very willing to support this hydrogen valley with buses in order to have the transportation for this region. We have also participated in a common project with CP Portugal, with the train, the big train company in Portugal, in order to convert a diesel train to hydrogen. So this is also a project where we are participating. And then we have signed non-binding letters with several other entities in order to collaborate to build up a green hydrogen mobility cluster in Portugal. So the government is supporting, and we are fortunately taking part in several projects that are running in Portugal in this area.
Okay, thanks, Patricia. I think that Dennis left us as anticipated. I would then move to Luis from his experience or point of view.
From our side, it's a lot of what Patricia just said. Portugal has a strong commitment regarding green hydrogen, as you know. Portugal launched a strategy for hydrogen back in the beginning of the year, and I think it was one of the first countries in Europe to do it. And after that, there was a call to companies to put together what they call an interest on hydrogen. We, as Bondalti, we put together a project to run for IPCEI, and that project is called H2 Enable, and the main goal is to have in Estarreja, in the complex, in the chemical complex of Estarreja, an hub for hydrogen, green hydrogen, to produce green hydrogen, not only for our producing needs, but also for the region. And also this project is based not only on green hydrogen, but also in green ammonia, which is critical for us and for the companies in Estarreja, like Air Liquide and Dow Chemical, but also as an export carrier for hydrogen, at least in a short term. And so this was our project. We also are doing a lot of meetings and partnership agreements with other companies, not only for technological issues, but also for off-taking of the hydrogen that we will not use in the complex. And what we are seeing right now is what we have talked a couple of minutes ago, which is there are still a lot of moving parts, still a lot of undefined an undefined roadmap about next steps regarding IPCEI, and so we are following that very carefully. Also, how the financials will be put together. The financing, like Christian was saying, is critical for these projects, and of course we are also working in that side. There is something that's important also about our project, which is how water can be a huge part in this. We in Bondalti acquired a water treatment company in the past month, also to answer this issue, how to get the right water. As you know, it has to be specific requirements, and we are also working in that field also. So let's hope the IPCEI can be clear in the near future. Let's hope that all the companies that work in Portugal around this can have a common, at least, understanding about to put this together. And of course, we Bondalti will be and want to be a very important part in all this ecosystem.
Thanks a lot, Luis. Jorge, what do you think about this initiative, the IPCEI's, if you are involved as well?
Okay, the question is for me?
Yes, Jorge.
Yeah, okay, yeah. We have participated also in the call from the Portuguese government with our project to produce green hydrogen offshore with offshore wind in our Hexicon platform. And we are very happy with that. And we are waiting for the next steps from the Portuguese government.
Okay. Christian, how important is this instrument for you as an investor, let's say?
For us, in fact, it's a very good initiative. It gives the frame to have projects which have the right then to get the corresponding subsidies in the corresponding countries. It also enables the interaction. In fact, what I really liked, we had also projects in this expression of interest in Portugal, and then also the linking of different stakeholders in the value chain, which was also very much supported, which is effectively what needs to be done, because any one of us can do his part, but without the others being linked and doing the same at the same speed, it just doesn't work out. So I would say is something which is I think a very good initiative, but it's just one part of the next steps then, which are the real projects to be done. And as you mentioned, also the European context, obviously it's also great that this enforces also the working together on European level. As we know, for example, the gas grid is not just separated between countries, it goes together. So there's a lot of things to be connected. We are also active in Spain in a corresponding projects there. I think in Spain is there are some industries which really have a hard target on the carbon emissions and which really need to act. And this IPCEI also is helping in this direction. And also I'm myself sitting right now in Germany. Germany is more on the engineering side, also launching an expression of interest very soon. And this is then more on the engineering side as the conditions for generation. This just the wind good, the solar is critical, but also there will be some project, but obviously some other southern countries are more engaged. But this IPCEI, I think, is a good initiative to put all these bonds together.
Thanks, Christian. And what about your point of view, Didier, as a big multinational company with operation worldwide? I think that this is a unique opportunity, I think, to exploit this instrument, I guess.
IPCEI is a very interesting, as Christian said, it's a very interesting tool to bring stakeholders together, different stakeholders from the value chain, but also the stakeholders spread geographically. Our only concern a little bit with IPCEI is the admin and the time. Sometimes, if 2 or 3 companies are privately creating or starting a project, it goes much faster. You see, and that is a little bit, the question is here, IPCEI, and honestly speaking, it has to exist, no doubt. But IPCEI should really try to be, at least the concept should try to be faster so that companies can really act and focus on the project itself. Okay, and not only on the discussions. Now, we are very interested in IPCEI because it brings, as I said, the people and the stakeholders together, and it's covering not one single member state, it's covering multiple member states, which is very interesting because in some cases like pipelines you have to you need that. In some cases like clusters that would cover 2 or 3 member states on a border, you need that because otherwise it doesn't work. But sometimes it should be faster because, as I said, for us, one of the challenges is time. We want to really move on, and we can move on fast enough. That is a little bit the challenge we have with IPCEI, despite all its advantages. Okay.
Okay. Thanks a lot for your.
But of course, we are in a very fortunate position, being Toyota.
Okay. Thanks a lot, Didier. One of the person which is connected with us in the roundtable is putting a question about water being at the core of the hydrogen economy. I mean, it's one of the key resources and is sometimes scarce. In some of the countries there could be issue with that. I would like to ask Christian first, as an investor, I think when deciding to put money in some projects, is water availability one of the criteria? I mean, is this a topic that you are deeply investigating when entering into an investment project?
Absolutely. Actually, this is a kind of a go, no-go topic, kind of a hard fact. If you do something and there is no water availability and the regulation do not allow that you have a water supply, you need either find a solution or this project is just not possible at all. Even if there is projects where there is a risk on the future, because we know we are fighting climate change, but the climate is still changing. So maybe some decisions we are doing now will change over time. We're doing investments on a 30-year basis of operation. And if the water resource, as you said, is the essential thing, we need to even to think about the long-term view here. There are technologies. The one thing is obviously the wastewater topic, that this is, as also Luis mentioned, that they are investing into it. This is a very good usage also in the future. Desalination so far is an energy efficiency topic, and there are some technologies trying to do it better. But absolutely, as an investor, this is a kind of a go, no-go thing. And in fact, we are looking into it.
Okay, thanks. I would like to ask to Jorge from the technology side instead. You are in the business offshore, desalination. I mean, which could be the big challenges for this in the future?
Okay, there are a lot of technical challenges because it's new. What we want to do is to produce electricity offshore with floating platforms, and these floating platforms are ready to hybridize with other technologies. We can produce, once we have electricity offshore, we can desalinate water, we can produce hydrogen, we can produce ammonia. So there are a lot of research to do yet, but it will come. So our approach is with the offshore platforms to produce through the wind electricity. And the main thing is that we have a lot of resource, of wind resource in the planet, and a lot of wind resource offshore. The question is that if you want to take advantage of this resource, wind resource, you cannot connect to the grid, because in all countries we have restrictions with the grid, electricity grid. So the way to take advantage of the wind offshore is to produce it offshore and to use it to produce hydrogen offshore too. And this is our path now.
Okay, thanks. One of the questions was about when we are going to drive or to use transportation means using hydrogen. I would like to ask to Patricia, which already mentioned the lack of infrastructures of today, when this will be a reality. I mean, when your buses will be moving around and we will be having the possibility to use them more massively, let's say.
Well, yes, the buses and the cars, they are already available. The technology is there, and we have buses running already, and we have countries which have some infrastructure already. So the bus itself, the asset is there. Also the infrastructure, I mean, the refueling stations, they are providers for all of this. I mean, the value chain, even for the producers, the electrolyzers, the way how to produce electricity for all this is there. It's really a question now of putting this in an economical way. And again, I think we can drive cars and we can drive buses immediately. The issue is only we need scale. Again, like Didi said, we need scale and we need this to be fast. And this is like a little bit a cycle. Somebody has to start and somebody has to put the scale into this cycle, because infrastructure, assets, the way how to do it is already available. It's now really a push that we need from, and the support that we need from the stakeholders, from all the stakeholders, in order to put this moving. So if you want to drive a car tomorrow, you can.
Thanks a lot. What about your point of view, Didier, as a big multinational company on this?
Yeah, I fully support what Patricia said, but let me say it depends sometimes a little bit where you live. Allow me to explain. EU is developing a kind of hydrogen corridors. Now, they will really concentrate investments on hydrogen corridors. One of the first ones that will be developed is the one from Denmark to Italy, crossing Germany. There we see already a huge number of hydrogen stations. And of course, it's easy to drive a hydrogen car everywhere, but you will see that their clusters will come or exist already, but it will be developed and it will be, how would I say, implemented in some areas. And then there will be another area and there will be another area. So it will be in phases, okay, especially for the development of infrastructure. Producers or installers of hydrogen stations, they look where there are vehicles. Producers of vehicles, they look where there are hydrogen stations. So it's always a chicken and egg story. So we try to each other to say, okay, where are you going? Okay. And we say, okay, maybe there is a potential of, for instance, a taxi fleet. I just give an example of 200, 300 cars. Okay. I cannot sell a car to somebody if there is no station in the neighborhood. Okay. So I need to talk to a producer of hydrogen stations to say, okay, are you going to that area? So, and that will develop, or that will determine where you will be driving massively hydrogen cars. Even if today you can drive a hydrogen car already in Portugal, no problem at all.
Okay, thanks a lot, Didier. I think that we have almost approached the end of our roundtable. There is still a question that I see about what about nuclear supporting hydrogen generation? And I would like to pose this question to Christian from your investment radar point of view. I mean, is there any discussion or any project being conceived or developed in this area? I mean, combining nuclear and synergy with hydrogen generation.
I must say, maybe also by personal opinion, not at all. I'm a physicist and have done really also nuclear physics in my studies. And it's a great physical technological thing, but we have learned our lessons that it's kind of, we don't have a long-term solution. So for pure decarbonization, it could be a good idea. So if there were no other options, it would be a good idea. But we have learned that, especially in Europe, but actually this is valid for the world, the risks and how to manage this long-term is a risk. And as we are talking about investments, that's what, in fact, investors don't like risk. So by that already you have kind of the answer what kind of my opinion is, and also from our side as MAM Energy, we see better options, and so don't pursue this path.
I'm just looking at the other question. Are there technological challenges regarding hydrogen that the collaboration between scientific research and the industry could solve? I think that we have touched upon this in the first question already, but is there any specific challenge where joining forces with R&D and industry would give a strong contribution in accelerating one of the gaps that you mentioned? Maybe we can ask this to Luis?
Yeah, we touched that issue in the beginning. I think so. We are a strong supporter of having collaboration with R&D departments at universities or companies. Actually, I think Patricia mentioned that the idea of having a collab that we already have established in Portugal with companies, with universities, with off-takers, with technology partners. It's a very good way to promote this connection between companies and R&D, and I think that's one of the ways to move this forward. Not only to find new areas of development and to once again to bring the costs down of all the value chain, but also to bring the hydrogen as a main topic to universities and to the students, and to be able to bring to have in their minds that the hydrogen can be a very important way for them in the future to work with in companies that are developing projects. So yes, it will be critical to have a very good connection between R&D companies or R&D departments at universities with companies that are developing projects in this field.
Thanks, Luis. Another question: how can hydrogen decarbonize the waste sector? Are thermal processes, electrolysis, and methanation the way? I don't know if some of you have a specific answer for this. Otherwise, maybe Christian, from your neutral investment point of view, you see any contribution? I mean, for decarbonizing the waste sector as well.
For sure, there are good opportunities. There's a lot of chemical processes which can be applied with hydrogen and also replace other processes. You can also, how can I say, methanation, obviously, is something which is done already today through hydrogen. You can also optimize it. So I think there are a lot of options. We haven't looked ourselves really into it yet, I must admit. So I just say out of my head that I think there are good options.
Okay, I don't know whether Jorge, do you see any contribution to this, to the decarbonization of the waste sector? How do you see this opportunity?
Okay, this is not my field, sorry. We are working with hydrogen from the point of view of the protein platforms, and I am not a specialist in this field, so I have an opinion. But of course, the waste sector is very important, and it needs perhaps more research about it. Okay, but I don't know. Sorry.
Okay, thanks a lot, Jorge. Last question is about safety. Maybe we can close the roundtable with just a few words from each of you. I mean, starting from Patricia, how do you see safety as an obstacle or an opportunity maybe to develop new knowledge as it was maybe in the past with other sectors?
So I think that, like we already stated during the conversation, safety in this sector is really very, very important because it's a new technology. From our point of view, again, as end user, we focus a lot on the skills of safety in this product, but it's not being so much different from other products that we had already built, like the electric vehicles. When they came in, it was also something new. We also had to take care of the safety issue. And we also produce gas buses, and gas buses also have the issue. So from our perspective, the safety skills, they are really, we have to take care of them, but in the end user side, in Caetano, these are not at the moment the ones that are giving us more headache, I would say. But for the complete value chain, safety is really the critical issue, yes.
Thanks a lot. Luis, your opinion?
Yeah, I mentioned that before. Safety, it's a very, very important issue. It's a challenge right now. I think it's going to be very, very important to deal with it. As you know, in the chemical industry, safety is very present in everything that we do. But hydrogen, mainly the storage and transportation of hydrogen, whatever form it takes to transport, we need to pay attention to safety, how to do it, how to avoid any kind of issue with mainly the transportation of huge amounts of hydrogen in liquid form, in ammonia, whatever. Because the price, if we have some kind of an accident or some kind of an incident, I think will jeopardize part of the efforts that we are doing. So we are putting a lot of effort in trying to have people with the right skills in this field, and of course to reinforce all the processes regarding safety, the ones we have and the ones that will be specific for dealing with high amounts of hydrogen in the near future. So it's a topic. It's important. It's very important, but I think it's manageable. But we have to be aware and we have to take all the questions.
Okay, I think that the organizers are telling to me that we have reached the end of the session and they need to move on with the digital program. I think that we have covered all the key points and I hope that we got also valuable inputs to the people which are attending. I would like to personally thank and send my applause to the participants and leave the floor to Jorge for the final remarks.
Thank you. Thank you so much, Stefano Carosio, and thank you to all the invited participants for this excellent roundtable. Now it is time for a short coffee break. Please remember that you can take advantage of the networking area. We encourage you to go there and meet other participants. You can also know more about INL in the exhibition area. So see you again in 15 minutes. Thank you.
Thanks a lot.
Thank you. Thank you.
Thank you.
Thank you very much. Bye.
Bye-bye. Thank you.
Bye.
Hello and welcome to the second moment of the day, the session on hydrogen technology development. We will have with us Juan Rodriguez Fernandez Arroyo, Director General of Energy Lab, Carmen Rangel, Hydrogen and Batteries Unit Coordinator at LNEG, João Abel Peças Lopes, Director of Inestec Porto, Emilio Nieto Gallego, Director of the CNH2, José Neves, President of the AED Cluster, and Sasha Sadavasar, Coordinator of the INL Clean Energy Cluster. The moderator for this session later on will be Paulo Ferreira, Deputy Coordinator of the INL Clean Energy Cluster. Right now, we will have short presentations by each one of the speakers. So I call now to the stage Juan Rodriguez Fernandez Arroyo. Welcome, Juan.
Thank you very much, Jorge. Well, first of all, I want to thank the INL for its kind invitation to Energy Lab to participate in this event. Good morning, everyone, participants and attendees. So I'm going to do a brief presentation of Energy Lab and its work lines related to hydrogen technologies and also our general overview of the topic. So Energy Lab is RTO, a research and technology organization focused on energy efficiency and sustainability. We are located in Vigo, in the university campus of this city, which is in the Galicia region in the northwest part of Spain and just 100 kilometers to the north of the INL. So we have 4 main areas of work, which are the green buildings area, industry area, sustainable mobility and infrastructures area, and also bioenergy area. And it is in these last 2 areas in which we carry out for years our work related to hydrogen technologies, which well, we can divide into 3 main issues that are hybrid propulsion systems, hydrogen-based, in which we have experience, for example, in the maritime sector with fishing vessel sizes. The second, hydrogen as a raw material. Specifically, we work in the combination of hydrogen and carbon dioxide that may come from CO2 capture or from a biogas stream, for example. For the methane production in biological reactors, in which we have experience at lab size and also at industry size. And in third position, new methods for obtaining green hydrogen. Currently, we are also working in hydrogen production from biomass, specifically from organic waste, through biological and also thermochemical routes, in in the first with biological routes. We are working in dark fermentation, from anaerobic digestion, and in the thermochemical route we are working in gasification for the obtaining of hydrogen, of green hydrogen. So as we see the actual frame related with the energy transition and the greenhouse gases emissions reduction main goal, is in a great opportunities frame to develop the hydrogen technologies at all levels for its large scale implementation in different use cases, like the diversification of green hydrogen generation alternatives, the use in mobility sector, industry, also with injection in the gas network, etc. But we think that must be accompanied with an appropriate legal framework that allows its effective implementation and of course a scale economy that allows the cost reduction. In this frame, we think that RTOs will have an important role in order to help accelerate technology deployment in business and also in the market. So until now, this initial introduction from Energy Lab, from our general overview of the topic and with the theme of this session. So we'll be able to comment in depth on these issues throughout the debate, and also with the questions of Paulo or with the questions from the attendees. So thank you very much.
Thank you so much, Juan. We now welcome Carmen Rangel. Good morning, Carmen.
Good morning. Have we got an image?
No, we have no image.
But okay, I have activated the image. So good morning to you all. Thank you for the invitation. I am from the National Laboratories for Energy and Geology, located in Lisbon, which work primarily, as the title of the laboratory says, in energy and geology through different units, the materials for energy units, the biotechnology units, the renewable energies and integrator units, and also an economic unit about economy of resources. So I will start by saying that this is a strong push to limit carbon emissions and the falling of the cost of renewable energies and the major incentive at the European level, such as the projects of common interest and the Green Deal, have given a good opportunity for the research and development in the next decade to be supported. But this research to be supported is not only in the new developments for more emerging technologies regarding hydrogen, but also the support of research and development necessary to lower the cost of scale-up technologies. We have seen since 2015, for example, a dramatic fall in the cost of electrolysis, and also we are expecting further reduction due to the scalability factor, and are also advances in the multi-stack system and manufacturing. Regarding the research, we focus in new materials and aiding electrode and component design for fuel cells and water electrolyzers in order to comply with the specific targets of cost, efficiency, and lifetime. Those we do through functionalization of supports and nanocatalysts for reducing platinum loading and other platinum group metal materials which are scarce and very costly. We also address the durability aspects and the reliability of materials and components. We can talk about that later on because we focus also on the study of aging and degradation mechanism in order to propose accelerated protocols that will allow us to reflect more the testing in real conditions, especially those regarding dynamic operation due to the coupling of electrolyzers, for example, with renewable energy. Another aspect that is being referred to and is important is the feedstock water for electrolysis, because the need obviously exceeds the stoichiometry of the reaction, and the choice of water is very important. We are also focusing on that and examining the choices, for example, of wastewaters as appealing options. And also we are focusing on seawater electrolysis. We can talk about that also later on. The effect of transient operations in all this, as I say, is very important for stack and system lifetimes because they are not well quantified. So available data on durability, voltage degradation, and stack lifetime are normally given in for constant current operation conditions and nominal power, and that's not what is actually needed. Cross permeation of gases is also an important topic regarding to safety issues in these kind of technologies, and also membrane development, because this is also to do with part-time loading operation of these devices. It is also relevant to mention, for example, water splitting using wastewater in the context of photochemical process, which are not very well developed for the production of solar hydrogen. That's very important because we can use visible light irradiation if we got the right materials and if they are efficient and durable, and also to develop more large-scale photoreactors. Also, there is a research going on in materials for solar thermochemical production of hydrogen, means green hydrogen production using concentrated solar energy as a heating source for water splitting using specific compounds. Also, we cannot forget the transversal issues, which are very important to the support of a stakeholder, such as technico-economical analysis and environmental aspects analysis for the different technologies all along the value chain of hydrogen, in order to allow sound decision-making and robust cases for business cases required from the stakeholder. And also, I wouldn't like to leave for last the mentioning of the need for training and education in this area. Dedicating and specialized knowledge is necessary, and public awareness of the technology is also important for the establishment of a new paradigm having hydrogen technologies as a base. So I will leave it to that because time is pressing, and thank you very much for listening.
Thank you. Thank you so much, Carmen Rangel. We now welcome João Abel Peças Lopes. Good morning.
Okay, so good morning to all of you. Well, let me start first by thanking the invitation to participate in this panel. So I'm coming from INESCTEC. INESCTEC is an interface research institution situated in Porto. We have also some other poles in University of Minho and University of Trás-os-Montes and Alto Douro. And we are one of the largest research institutions developing research in energy systems in Portugal. So we are looking very carefully at the challenges that the hydrogen is bringing. And so when dealing with hydrogen, we understand that we have the fact that we need to decarbonize the economy. And to do that, we need to electrify largely the economy. But by just doing the electrification of the economy, we will not be capable to completely decarbonize the economy. And so we understand that it is necessary to find out and use a complementary vector that is hydrogen. that will be extremely important to deal with, for instance, industrial heat production, to be used in manufacturers of steel, cements, glass, ceramics. And we also understand that it's important to try to incorporate as much as possible hydrogen and natural gas for different utilizations. And this means that we have to deal with challenges of operating the natural gas network with a blending of hydrogen, and this is one of the issues we are addressing. So we also understand that hydrogen is one of the most promising decarbonizing options for heavy, dirty, and long-range transportation, for trucks, buses, ships, trains, and in the future, also aircrafts. And some of the areas where we do our research and where we think hydrogen will represent an important contribution is that since we are nowadays having an electric power system that has a tremendous amount of large-scale integration of renewable power sources, it is extremely important to be able to provide energy seasonal storage capability. And this is important to cope with some surplus of electricity from renewable power sources coming from PV generation in summer that we want to transfer to winter. We also think that by doing that, we will contribute to improve the security of supply by improving the reliability indexes of the electrical generation system. And this can be done by exploiting the hydrogen blended into natural gas, and that is afterwards going to be used at combined cycle gas turbines, or also using cogeneration fuel cells that will inject electricity in a gas to power approach. And this means that we have to study issues like capacity payments for those solutions, and this will become additional revenues for the value chain of hydrogen, and this will contribute to lower the costs of production of hydrogen. Also, the electrolyzers, they will be capable to provide flexibility services to the electric power system by providing primary and secondary frequency regulation services. And these services are remunerated services, and again, this will become an additional revenue to lower the costs of production of hydrogen. Also, the presence of hydrogen and the possibility of linking it with the electricity sector, this allows to develop the sector coupling between electricity and gas and creating indeed an energy market. And obviously that we understand that there are several research activities that are needed. So we will need to look carefully to the reduction of the hydrogen production costs at the CapEx and OpEx, electrolyzers cost reduction. We want to, and we are looking carefully at the power electronics and the energy management control systems for these electrolyzers, because they will have to deal with the huge values, huge current values. We obviously look carefully at storage and distribution of hydrogen and all the problems, technological problems that it brings. And so we also look carefully at the need to develop critical tools and industrial solutions to boost these hydrogen technologies. And obviously, as already mentioned, we want to help in training high qualified human resources and to afterwards to contribute to export valuable knowledge in this field. So we do believe that there is room to create a hydrogen cluster that at the end will enable the Indonesiation of the knowledge in order to create value. And so we have in Portugal, and not only in Portugal, but in Europe, and Europe wants to lead this way, this path that includes hydrogen. So we have a tremendous opportunity to export hydrogen, to produce new industrial products and services, and obviously to export them. And so thank you very much for listening to me.
Thank you so much, João Abel Peças Lopes. The next presenter, Emilio Nieto Gallego. Good morning and thank you for being with us.
Hello, good morning to everyone. I would like, as my other colleagues, in order to thank the organizer, to invite and to count with the National Hydrogen Center here in Spain in order to give a lecture here and try to talk with some colleagues, and some of them are already friends because we are also having the opportunity in order to meet together in this kind of events. So I have 4 minutes, so I would like, in order to give you a small presentation of who we are and where we are and which are our strategic lines. And the National Hydrogen Center, this is a research and development consortia, belongs to the administration. We are starting in 2007, and we are 50% of the central government in Spain, and the other 50% of the regional government belongs to the area where we are. We are located in Puerto Llano, Ciudad Real, who is 250 kilometers to the south from Madrid, and this is connected with a high-speed train between Madrid and Puerto Llano. All of the activities we have is linked with the hydrogen and the fuel cells value chain. We are covering the whole value chain. We are more or less 50 people working here in this field, and we are covering all the TRLs development. So we are making some basic research, and also we are finished with the TRL 7 and 8 in order to demonstrate and validate all the different prototypes production in industrial environment. Our strategic lines are covering, as I told you before, the whole value chain. This means that we are working in the different methods for the production of the hydrogen. We are working on how this hydrogen, when it's produced, is possible to store. Once you are storing, we are also working in the different kind of fuel cells already in the market in order to transform this hydrogen produced in the electricity. Once we have this electricity, we are also have some strategic lines from the different applications, and not only considering the stationary application, but also the mobility application where it's possible to apply all the different developments and technologies related with the hydrogen and fuel cell. And also we have another 2 more strategic lines that one of them is linked to the safety and regulations. So it's quite interesting and a need in order to work together with the different office from the Commission and Europe in order to help and try to define all together how will be the next standards as a European level. And also another strategic line we have is the, let's say, cross-cutting issues. And these cross-cutting issues are all the different things more to the society, the information, the formation, and also all the different techno-economical analysis, and try to help the sector in order to understand what is the hydrogen and fuel cells and how this could help the society in order to move forward to reach and to comply with the different objectives it was already defined. In order to perform all these strategic lines, we are a very huge amount of capabilities here in the center. We have 13 labs who are covering each of the lab, all the different individual strategic lines on the different part of the value chain. And also we are focusing, but not completely, because you can imagine that only working in the green hydrogen, it will be also very few right now, but in the next future, with all the different roadmaps that is already defined, not only in Spain, but also in another different countries in Europe, it will be, let's say, the next 10 years, very exciting in order to help all the industry to invest and to develop all the different applications in order to move forward all together. So this is all only in order to give you an overview where we are and where we are located, and which are the main activities we have. And of course, all the different activities are around this complete value chain. And we are working not only in private contracts as a subcontractor for the different private companies, but also we are working in different projects, not only for Europe, but also international and national projects. So I think we will have the opportunity later on with the questions in order to give more in detail. So I will stop here because the time is running and there are a lot of more people to talk. Thank you again.
Thank you, Emilio Nieto Gallego. We now welcome José Neves with an interesting perspective and the not so commonly debated use for hydrogen.
All right, thank you very much. First of all, I would like to congratulate INL for this initiative and in particular for including the ID cluster in the agenda. Actually, yesterday I had already the opportunity to watch some of the presentations, and I did notice that in the afternoon there was already some discussions about the aeronautical sector and the impact in the fuels. So I think it's quite interesting to see that the issue of aeronautics was already addressed yesterday. First, not being a hydrogen specialist at all, rather I'm an aerospace engineer and here as president of the ID cluster, I really would like to take this opportunity to take a few words to talk to you about the revolution that we will see in the aviation sector over the next 2 decades. And I think it's important to have this time to present that. Still first, and for those of you which do not know, the Portuguese cluster for aeronautics, space and defense, so IAD there, involves already 87 members, including companies, institutes and academia. The overall turnover of this ecosystem in Portugal is in the area of 1.7 thousand million euros, represents 1.4% of the Portuguese GDP and more than 18,000 jobs, which is quite interesting for a relatively new sector. Just a benchmark to start, 10% of the decline in the global CO2 emissions attributed to the COVID-19 pandemic was the result of the reduction in air transport operations. Considering that air transport contributes to roughly 2.8% of the global CO2 emissions, this is not only a stark illustration of just how much aviation has suffered in relation to other industries, but as well of its relatively high carbon intensity. And I think it's important fact that I will address during my talk. Nonetheless, let me tell you that fuel consumption per passenger today is around 47% lower than compared to the 90s. However, the number of passengers did increase 4 times in the last 30 years, as you'll notice. As stated by this year by Commission Maria Gabriel, environmental sustainability is a key challenge for this sector, which falls under the European Green Deal, published by the European Commission last December. This deal means and aims to transform the European Union into the first climate neutral continent by 2050. And of course, the aviation sector will be no exception. Considering that climate change has become a clear concern of our society, and we've talks every day about that, and last year we had big speeches from Greta Thunberg also talking about the aeronautical sector in particular and aviation. This sector is today highly mobilized for this endeavor, and European research has already started for many years, fostered by the industry, by the Clean Sky joint undertaking over the last decade, and in the future under the Horizon Europe by the Clean Aviation joint undertaking. Being the decarbonization a major challenge for the aviation, the research done so far indicates that hydrogen propulsion can really significantly reduce climate impact. It's not only me saying, just last September, Guillaume Faury, from the CEO of Airbus, has revealed 3 concepts for the world's first zero-emission commercial aircrafts, which could enter into service by 2035. So just 15 years from now, which for aviation is quite fast. And the idea is to have really the first flights, let's say we call it maiden flights, by 2025, so 5 years from now. The proposed approach explores various technology pathways and really includes technology and aerodynamic configurations really to support our vision, the European vision, to lead the way in decarbonization of the entire aviation industry. As important, and we can always never forget this, in order to tackle these challenges, airports will require significant hydrogen infrastructure changes to meet the needs of daily operations. And I want to emphasize this because this means that a holistic solution really needs to be in place involving the entire ecosystem. Being today strategic for Europe, this sector, from an industrial perspective, I must say that support from governments will be key to meet these ambitious objectives, with specific funding goals to be put in place for research and technology development, digitalization, and, as important, mechanisms that can encourage the use of sustainable fuels and the renewal of aircraft fleets to allow that airlines can retire all the aircrafts which are less environmental friendly earlier. And why this is important? Well, above all, there is not today clear turnkey solution for this problem. Battery electric propulsion has zero in-flight emissions, but is limited to battery density, and the battery right now is only viable for smaller to short-range aircraft. Hydrogen electric propulsion using fuel cells enables larger, longer-range aircraft with zero in-flight emissions. Still, fuel cells are not expected to reach the power density needed, namely for single and twin aisle aircrafts. So this gets interesting when we see that electric and hydrogen technologies could actually come together in a hybrid form of propulsion. For you to have an idea, Airbus is considering the usage of fuel cells for takeoff only as a complement to turbine engines. And then liquid hydrogen fuel can be used in direct combustion, enabling what we call it the zero emission aircraft. Just some final remarks. Hydrogen propulsion is really a disruptive innovation in aviation. But will require really significant research and development, investments, regulation to ensure safety, and really we need to catalyze a complete transformation in the aviation industry, from aircraft certification to pilot training and even airport design. From the IAD side here in Portugal, we are closely following this process, and we do have already an internal task force looking for innovative ideas and concepts, as well to identify new partners which can come out from the usual aeronautical footprint, let's say. Just to finalize, since we are running out of time, and it's just 4 minutes, so to finalize, I would like to reinforce that this is an historic moment for the commercial aviation sector, and really our cluster in Portugal really intends to play a role in the most important transition this industry has ever seen. This goal can really create a revolution in Portuguese industrial and academical sectors, and in our overall ecosystem, and really pave the way for becoming a reference nation in this aviation sector. And that's our target. And that's I would like to thank you the time to listen, and I'm ready, of course, for some possible questions that you may have. Thank you.
Thank you. Thank you so much, José Neves. And now for the last presentation from Sasha Sadavasar from INL. Welcome, Sasha.
Thank you very much for the introduction. And of course, it's a pleasure to also represent INL here in this Hydrogen Summit. So I'm the coordinator of the Clean Energy Cluster at INL. And today, of course, I will focus on our hydrogen research and development activities. And maybe complementary to the other speakers in this panel, we have a strong effort on materials research for hydrogen technologies. So maybe first a few words about INL. We are an intergovernmental organization, and our vision is to become a recognized global nanotechnology innovation hub. And our stated mission is to explore interfaces. And of course, one of the interfaces that we already heard in this panel is the transition from academia and research into industry. But there's more aspects that we understand with the interfaces. I will come back to this in a second. At the moment, we are about 350 to 400 people. We are organized in 25 research groups, and our research and technology activities are actually organized since the beginning of this year in 6 different clusters. And they range from personalized health tech to food, advanced materials and computing, smart digital nanosystems, sustainable environment, and finally the clean energy cluster. Within the clean energy cluster, we have 3 topics. Hydrogen is one of them. Of course, that's the one that directly relates to this event. But we also work on photovoltaics and batteries. And obviously, since we are talking a lot about green hydrogen, which is of course the final goal, these 3 actually go quite well together in terms of the challenge of the green hydrogen. But actually, now coming back to the interfaces, we don't isolate this part from the other activities in the other clusters. So for example, in the sustainable environment, we are looking at risk-free environment, and this of course is related to safety and also to waste and so on. So there we clearly have an interface. Even more with the smart digital nano systems, we are working a lot on autonomous smart sensor networks, and of course for monitoring air quality, water quality, And so on, these such sensor networks are highly interesting. And eventually also with the computing, there's an interface with hydrogen, as there we're looking into neuromorphic computing, which of course would make for low power sensors that can be used then again for hydrogen monitoring. So in the end, we have interfaces between a lot of our activities, and we don't isolate only the hydrogen element in itself. So within the clean energy cluster, we are developing solutions for low carbon, renewable and recyclable energy technologies. And we focus on essentially on proof of concept and the technologies and prototype devices. And here we tackle, as said before, photovoltaics, hydrogen technologies and rechargeable batteries. So specifically within the hydrogen technology, we cover and we do this mainly on a materials aspect. We cover the production of hydrogen, storage and transport, and also CO2 conversion. So more specifically, we look into novel and efficient catalysts and electrolyzers. We are looking in photocatalysis, which of course is not yet a viable technology, but we of course, as a research and development organization, we look a lot into the future. We are working on sensors for monitoring water quality. Then in terms of the storage and transport, we are having activities on liquid organic hydrogen carriers and also catalysts for hydrogenation and dehydrogenation of these. And then sensors for safety control is also a competence. And then from the CO2 conversion, of course, we also work again on catalysts to enhance CO2 conversion into fuels, and also catalysts with platinum group free catalysts. So normally our flow in terms of working is that we look into the design and the synthesis of materials, but also the design of devices. We do computer simulations to understand better what the materials properties are and what the devices should look like. We do performance testing, and this is all supported by advanced characterization. So we have two large facilities at INL. One is a nano fabrication and microfabrication clean room, which is supporting, of course, also the activities in the energy field. And then we have a very advanced microscopic and spectroscopic characterization possibilities. So all of this converges in the end in understanding materials better and getting the best out of them for the technologies we work on, and here, of course, for the hydrogen technology. Thank you.
Thank you so much, Sasha, and all the invited speakers. The debate will now be moderated by Paulo Ferreira from INL.
Good morning, everyone. So my name is Paulo Ferreira. I'm the Deputy Coordinator for the Clean Energy Cluster, INL, and also the Group Leader here, INL, and Professor of Material Science at IST at the University of Lisbon. I would like to welcome everyone to the panel. This is definitely a diverse and very interesting panel that has touched on various critical issues. To actually maybe start the debate, I would like to start with the topic of transportation. And it is interesting to think that the earliest attempt developing a hydrogen engine was actually reported by Reverend Cecil in 1820. He actually presented his work to the Cambridge Philosophical Society on a paper about the application of hydrogen gas to produce moving power in machinery. Since then, of course, hydrogen was used extensively in the space program, particularly because of the energy to weight ratio. But today, if we think that most of the current engines are combustion engines, my question is, does it make sense to have hydrogen combustion engine to make the transition to hydrogen economy smoother before actually moving into transportation driven by hydrogen fuel cells? So maybe I could pose that question maybe to Juan, since is within the mobility, and then of course expand that to maybe other people that can comment.
Okay, thank you very much, Paulo. Well, regarding to this question, I think that hydrogen combustion greatly improves emissions compared to the use of other conventional fuels. But still cannot be considered zero emissions. Yeah. In contrast, fuel cells only generate water steam as waste, which is why they are positioned as the only viable technology in terms of zero emissions. So maybe that we will have greatly improvements in emissions reductions with the combustion of the hydrogen, but we cannot speak about it or we cannot consider this like zero emissions combustion. So maybe that there will be another viable alternatives in the short term, that maybe the use of mixtures of hydrogen and methane in natural gas engines, but also they need substantial changes in the design of these engines that well maybe that couldn't see this solution as an appropriate solution for it in cost terms. So well, I think that for the start of the question, I think that these are our main reasons for thinking that. Thank you, Paulo.
Well, yeah, thank you. I was wondering if someone would like to follow on this particular question, whether to transition first to a hydrogen combustion engine before going into a 100% fuel cell technology.
Yeah, I can add that on the talks that I have at the ISA committee, which is our counterpart at the European level. I know that the engine manufacturers, namely Rolls-Royce, is actually analyzing that to use hydrogen in the current engines. That's something that is ongoing right now. And that's why we do expect to have the first flights with hydrogen combustion by 2025. But it's really something new. There's some startups already working also on hydrogen electric means. But there's, I think, as I mentioned, there's not today a silver bullet. The research that's been done. I was with Guillaume Free back in December last, well, one year ago, December 2019, where Airbus already had this concern. So this concern does not come from COVID-19, was already concerned from Airbus and from all the publicity around the sector of concerning the pollution provoked by aircrafts. And at the time, Airbus was still not taking a decision concerning electric, hydrogen and synthetic fuels. Currently, what the decision was taken by Airbus at the end of December was really, okay, hydrogen at least for medium and short range aircraft flights, and long range will keep on using synthetic fuels at least until 2050. But it's still something, I think, as I mentioned, very new in the aviation sector, where safety is always first.
So actually, on that, I will follow up and perhaps ask you about the flights on hydrogen. So I mean, I think most of the people would think almost immediately about safety issues when we talk about hydrogen in airplanes. We know that about 4% of hydrogen in the air will be explosive. So what are the challenges there in terms of having hydrogen technology driving airplanes?
It's a very important question. I'm not the right person to respond because I'm not an hydrogen specialist. I know that the challenges are wide. First, because the center of gravity of the aircraft is going to change. Second, because you cannot place hydrogen in the wings. You can only put it in the body of the aircraft. Third, even the supply chain, and Airbus already mentioned that, and Guillaume Fourier particularly mentioned that the solution for hydrogen aircraft does not come only from the OEMs, Airbus and Boeing and Embraer. It comes from the overall ecosystem because there will be a supply chain. But in terms of how we are going to keep the hydrogen in the aircraft, I cannot respond to you because that's something that is being analyzed, and I'm not really an hydrogen specialist. I know that the facts are great at the aircraft level, even in the training of the pilots. So it's something quite wide. But how it's going to be, let's say, storage, I cannot give you that details, unfortunately.
Right. Thank you very much. I still within the transportation sector. I think one of the major technology challenges is how to store the amount of hydrogen, particularly considering the constraints of weight and volume, efficiency, safety, and cost. I'm thinking also about the durability of these systems and the codes and standards for hydrogen storage. So maybe a question to the panel. So which of those you think are the most difficult to solve? Are the ones that are currently kind of the bottleneck for the technology? Maybe I can start with Carmen, maybe a comment on that.
Well, what I can say is that storage of hydrogen due to gravimetric density and volumetric density characteristic of hydrogen is being one of the bottlenecks for the implementation of the technology. Actually, for example, for the transportation, what is foreseen is compressed hydrogen so far at relatively high pressure. First, we have those demonstration at 350 bar, and then we pass into, in some cases, 700 bar, which is quite a high pressure for a moving object. So safety restriction and safety standards, which are we think underdeveloped, will be very, very, very welcome. This is probably one of the holes, let's say, one of the gaps in the development all along the value chain of the technology. So we need more pre-normative research and more establishment of standards regarding safety due to this problem of storage capacity of hydrogen. Another thing, of course, is a problem of materials development, of reservoirs, of linings, of pressure testing, sensors, all related to the question of the storage of hydrogen. So we are advancing, but still bottlenecks. Of course, for example, I think ENL mentioned organic hydrogen carriers, liquid. So those are options in specific circumstances that are under research at the moment also for the storage of hydrogen. Obviously, even if we can transport the organic carrier or the hydrogen organic carrier as a liquid, it will need hydrogenation and the hydrogenation cycles. And then there is a problem of developing materials because at the moment, well, we have the process low temperatures, high pressure, low temperature regarding these cycles, the cycles of hydrogenation, dehydrogenation. But the materials that are now utilized for this kind of process in order to have the hydrogen back, obviously are materials which are novel materials, platinum-based, ruthenium-based. So materials which are scarce and expensive. So we need to work on that as well in order to be able to have these liquid organic carriers. But it's an interesting option because they are liquid and that can be more easily transported. So that's an overview of the situation regarding the storage.
Thank you. I would follow on that. I think Emilio mentioned about they have a thrust on safety and regulations. I was wondering if you could comment on that, if this is now something that is being discussed, and at which stage are we of actually having regulations that and standards that can actually be applied.
Yeah, it would be a pleasure also. I mean, as I told you before, we are also participating in different European committees that is taking care of this kind of safety and regulation standards, you know, and we were discussing the last week, for instance, in order to inform to you that the next program, the next, let's say, fuel cell hydrogen number 3, who will be clean hydrogen, the name of the new program, you know, it will be also considering one of the parts of the cross-cutting issues in order to develop and try to book some money in order to that the people have the possibility to propose something on improving this PNR and focusing on regulations and the new standards. I think this is something that is, as Carmen was explaining quite well, because she was making an overview of the different aspects. All of them are already a reality. So this means that the most important is that all of the people who are working with the hydrogen knows the characteristics of the hydrogen and how to handle this hydrogen. One of the issues is the pressure, and I think compressed hydrogen is well known and they are well developed. It's true, as Carmen was explaining before, that there are a lot of people who are working in order to define new materials to improve and reduce the cost. But also we need to consider the liquid hydrogen, not only the hydrogen who are like in methanol or ammonia or even another liquid organic system that is also feasible in order to transport in the same volume higher density values. But as Carmen explained, we have the problem that we increase the cost of the process because we have another 2 steps, the hydrogenation and dehydrogenation. So you have also problems with the efficiency of the overall process. No? But I only want to give you an advice about the liquid hydrogen. The liquid hydrogen is, it was the last report, it was published by the Commission, the fuel cell hydrogen regarding the use of the hydrogen in planes. They are making a report to say that small and medium planes will be also working with the liquid hydrogen, and higher planes you have to think in another different way. So Jose Nieves, it was already explained quite well in the last question. So there is something that we need to evolve, and mainly we need to focus in order to achieve the economy of scale, to reduce the cost of the current cost of the hydrogen, and this is give us the opportunity in order to start thinking another different ways in order to store the hydrogen, because the hydrogen will be in the future a very much more than they are using now, and the most of them it's decided to be green. So this is something important to consider, because from my point of view it should be not to waste in order to think to use green hydrogen for a combustion system, because in the combustion system you always have some emissions, and this is not the best way or the clever way in order to make the effort in order to achieve the green hydrogen and try to lose this green hydrogen in a motor, you know. But this, as you said in the first question, is also a transition. And in the transition, we need to move of all and try to cover all the different solutions and try to define how will be the best from the different application. And batteries will be the room in order to have the small movements distance, and all the rest will be the hydrogen and the synthetic fuels. And we need to work with that.
Okay, thank you. I was going to move on to the kind of another topic and maybe ask João. So when we talk about stationary fuel cells, so these are units that can provide heat and power. So they can be used for decentralized power supply, like off-grid areas or situations where there is a high demand, as you mentioned, for electricity from the grid. Do you see this technology of these stationary fuel cells important for homes and buildings? And so what are the challenges with implementing those off-grid or within an existing grid, like a smart grid in some way?
Okay, thank you very much. So if we accept that those fuel cells are going to operate with electricity produced from renewable power sources, And assuming that, okay, this renewable generation costs nil because it comes from the sun or it comes from the wind, then in fact, we can use fuel cells to produce electricity in the so-called gas to power mode. Although the fuel cells, they still have a problem that they have a very low efficiency. But since we are dealing with electricity produced from this renewable generation, then this is a possibility. And obviously, then if we look at the off-grid situations, then it's interesting, but I still believe that batteries will provide a better option than fuel cells because they have higher efficiencies. And obviously, assuming in this case that in those off-grid situations, you are also using electricity from renewable power sources. But anyway, they will be small sites. And for those cases, batteries will be better than use a way to produce hydrogen, store it, and use it in fuel cells. So we will still have to wait for some time before having fuel cells with better efficiencies.
Thank you very much. We'll now take some questions from the audience, and I will ask Sasha now. There's a question here. Basically, how is science, or how does science can help this hydrogen economy, particularly in the case of materials? What do you think the science can do in this regard?
Well, especially looking at materials, I think there's a lot of possibilities, and we have seen over the last decades how material science has pushed technology further and further. And for sure, the way is, let's say, a bit slow. You cannot expect something that we do in the labs on the market in a year or two, and some of the hydrogen things have to move forward quite fast. And we have seen in the previous panel also, I mean, the transport issue to a large extent is essentially solved, right? I mean, you can buy a hydrogen car, you can buy a hydrogen bus. There's other issues that let's say prevent this from being a large scale solution. But there's for me the bigger question is not hydrogen or not hydrogen, it's green hydrogen. In order to I mean, nowadays hydrogen is causing a lot of CO2 still, and we need to go from that hydrogen to a green hydrogen. And there is a lot of challenges, scientific challenges that can be solved, and materials will of course play a large role in this quest.
But you touch on this kind of interplay between the synthesis and characterization, simulations and testing. Maybe you could mention a little bit about that.
Well, this is a typical development cycle, I would say. I mean, you come up with an idea, you try to maybe assess it by simulations, you realize a prototype, and then you test it, and then you improve it again afterwards. And especially in hydrogen technology, I think a lot of things happen at a very small scale. We need to understand processes like catalysis on the atomic level almost. So doing advanced materials characterization is very important to move forward, to improve efficiencies, and so on. And of course, this eventually will convert into things on the market, but it takes time, and well, we do not have a lot of time as a society. But that's, I think, why it's very important that all stakeholders work together on this immense challenge that we have here.
Thank you. And yes.
Paolo, may I add to that? I would like to add that in the research of materials for hydrogen technology, there are very, very stringent targets to be achieved. Whether it is for transportation, whether it is for especially targets about loading, about durability. And regarding addressing these aspects of durability and reliability of materials on themselves, for example, a catalyst integrated into electrodes or integrated into other components, very critical components, for example, like a membranes. So there is a need to integrate advanced tools for diagnostic, to the study of aging and degradation of these, in order to know the mechanisms, and to propose protocols that are accelerated testing, and that may reflect the operating conditions, especially, for example, in electrolyzers regarding the dynamic operation or coupling with the renewable energies. Obviously, we are talking about functionalization of materials. The supports of the materials is very important, since all of them are nanomaterials. Obviously, reducing the loading and the concentration of scarce materials for more common materials is a challenge. So the material science has a very, very, very critical role in the development of hydrogen technologies, and that will continue for some time, because we want to reduce the cost, we want to increase performance, increase efficiency of the process, and obviously the durability. And all of this is related to operating conditions that will be, in fact, very, very, very particular for most of the system, and very new, because those are technologies that are applied to very diverse sectors of the economy, and every sector with their specific strengths. Thank you.
Okay, so just one more question that I have here from the audience. Can there be a mix between gasoline and hydrogen to improve the efficiency of currently available engines? Maybe someone could touch on that. Is this Jose, you are muted. You're still muted. I can't hear you.
Okay.
Yes.
Okay. I was just saying that from my side, I'm not so much aware of that. As I mentioned, there's the mix between electric and hydrogen, not so much between the gasoline. What's going on in aeronautics is the mixture of kerosene, which is let's say the gasoline used by aircrafts, with synthetic fuels, which can go up today up to 50%. And that's the mixer that I'm aware of right now.
Okay, maybe
I think yeah, sorry.
Yeah, sorry, go ahead.
I interrupt you. Yeah, I mean, I fully agree with Jose, you know, about this kind of the future e-fuels, that it should be the best way. It was also surprising to me, the question, because I have no any background to see if someone is working in this kind of blending. What is important to say is that all the combustion are also suffering the Carnot cycle. So this is also a problem with you know, when you want to increase the efficiency of the process. So thinking that blending hydrogen with gasoline, taking care about all the safety issues, and you are under control everything, I have some doubts in order to increase the efficiency of the final process. So I think from right now, all the people are trying to think in order to improve the investment, and try to give more rationality to the different investment for the future installations, you know, in order to think how to blend the hydrogen produced with the natural gas, or how to transform this hydrogen in these new chemicals in order to improve the density. I think this is the more focus of the people who are working now.
Okay, thank you. Just one more question, since we are in Portugal and we have talked a lot about the electrolyzers. I was wondering about the using the seawater for electrolysis. So what kind of the general implications when we compare seawater with regular water? Just very quickly, maybe a couple of minutes, we have to finish. Someone that like to comment on that?
I can comment on that. We were quite interested in the water issues, and of course, in probably using made this study that will allow us to know more about, for example, residual waters or waters that have gone through to treatment, and also seawater electrolysis. But also not only desalinating the water and using it in normal electrolysis, but using seawater directly, or more less treated seawater, let's say. But we have a problem here and a challenge, which is the presence of these electrochemically active anions in the seawater that interfere and compete with electrolysis reactions, namely the hydrogen evolution reaction and the oxygen production reaction, which is very sluggish and more demanding because it's a multi-electrode reaction. When we have this chlorine or this chloride in the seawater, we are working in a potential domain that produces chlorine and produces chlorinated oxidants from this particular composition of the water. So it's favorably from the point of view of thermodynamics and kinetics. And then we have to find selective, efficient, and durable catalysts for this challenge, and also to avoid this window of the formation of chloride, as well as withstanding higher current densities that will foster industrial application of the technique. So we have to overcome some stability issues under the conditions, as well of the possibility of having fluctuating currents and fluctuating gas pressures when we are connected to renewables setup. So the choice of transition metals is one choice, but is still in the early research. Thank you.
Thank you very much, Carmen. I'm told I need to wrap up. So before we finish, I would like to thank everyone for this really interesting discussion, and very happy to have you here on the panel. And then I will switch the floor to George. Thank you very much.
Thank you.
Thank you, Paulo Ferreira, and also thank you to all the invited speakers we had here today. The HNL Hydrogen Summit is now approaching to its end, not before the closing remarks. In these 2 days, we got a little closer to what needs to be done for hydrogen to be part of the solution towards a carbon neutral Europe. We are honored to have with us the mayor of Braga, the vibrant and knowledge-friendly city where INL is headquartered. Mayor Ricardo Rio, welcome and thank you for being here with us.
Good morning, George, and good morning to Lars Mantelius, my dear friend, and thank you for this invitation to participate in this closing remarks session. Greetings to all the participants in this conference. I would say that this initiative is very useful and it has a great sense of opportunity because, as everybody knows, and probably throughout these days, it has been many times remarked, the European Union and all its countries, and obviously Portugal, has presently 3 big objectives. The first one is obviously the sustainability issue, the Green Deal, and the discussion on taking advantage of new sources of energy and the pros and cons of each of those sources, and the way that we can reach the neutral carbon emissions up until 2050, or maybe for some projects like the ones Braga is applying even before that in 2030. And second dimension, which is the competitiveness and placing Europe as a continent and a territory in which there are more economic opportunities, and taking advantage of the projects that will be on the forefront of the renewable energies and the more sustainable energies is obviously also, apart from the sustainability issue, a great economic opportunity. And finally, to place Europe on the leadership of the global innovation, on how we connect the knowledge centers, the companies, all the institutions, in many domains, and obviously in each of these that I mentioned. And taking all these three dimensions into account, I think that it is very important that all the parts and all the institutions in Europe have a word in saying how we can achieve these goals. And when a territory like Braga, which is a very dynamic territory, a very innovative territory, a very young territory, as George mentioned, has an institution like INL, which aims to be at the center of this type of discussion, I have to be very proud on a way as a mayor, but I also have to pay a lot of attention, because all these initiatives can only be successful if we link the knowledge centers to the agents in the territory. And the municipalities are also an agent in the territory and also have a role in managing one of the areas in which these subjects can have a very important role, like the transport system. And therefore, what I would like to say is that we will be willing to see the development of these projects and the involvement of INL. And obviously, we will make our city available to participate in all sorts of projects that can be pilot for new technologies, for new solutions that can take advantage of the hydrogen and other sources of renewable energy that can help us achieve these three goals that I mentioned. I hope that this is the beginning of a successful project, also involving INL and all its partners that are present in this conference. Thank you.
Thank you so much once again, Mayor Ricardo Rio, for your words and for your constant incentive. Braga is, as we know, a living lab of new solutions, new technologically developed solutions, and we are sure it will be so in the near future. And now for the final words, the International Iberian Nanotechnology Laboratory, Lars Montelius.
Thank you, George. Good morning, everyone. So it's a pleasure to be here now and say thank you to all of the speakers that have been here and all the participants. I think these 2 days have been really a forum for a vibrant discussions that have brought forward a lot of different concepts that I think are extremely important for the future. And we recognize, I think all of us that have been following this, that the need for research development, technology development, material science, the understanding, the need to have better advanced tools in order to follow and understand exactly what is happening, as well as the associated challenges with the transportation and storage and the utilization of different materials and methods. I think it's really a big need to have a strong research capacity, of course, in order to train people that will be the people that will take part of this ecosystem development that we foresee, everything from the supply chain to the OEMs. So I think it has been an extremely nice days to listen to all the participants, giving a lot of insights, and also seeing the kind of necessity of having summits like this to bring people together with different perspectives and discuss and talk with each other. It's the only way forward to bring everyone connected and able to do something that is remarkable. And hopefully this summit has contributed to a bigger understanding on the European scene, and also leading to a possibility for a stronger European leadership in the hydrogen transformation that we are witnessing now, which is a part of course, the clean energy transformation that we are just in the middle of. So I would like just to say thank you all so very much. And I would like to thank a big congratulations to George and his team, the backstage team that have made this possible in this kind of strange situation where we need to do everything digitally. The good thing is, of course, that it brings people together in a very easy way, which I think is fantastic. So thank you all so much. Bye.
Thank you. Thank you so much, Professor Lars Montelius, INL Director General. Until 12:15 GMT, you have the chance to take advantage of the networking area from INL Hydrogen Summit. We also thank Greenfest for the support provided in broadcasting this conference. On behalf of the INL team who prepared and brought to you this INL Hydrogen Summit, we thank to all the speakers and to all the attendees who joined us these two off days. Thank you so much, and we hope to see you soon.